Hi everyone, today we're going to be talking about the angles of triangles and isosceles and equilateral triangles. Our objectives for today are that students will be able to apply the triangle angle sum theorem, apply the exterior angle theorem, and use properties of isosceles and equilateral triangles. Let's get started. Alright, so the first theorem we're going to talk about is the triangle angle sum theorem. The triangle angle sum theorem is basically just a fancy way of saying that the sum of the measures of the angles of a triangle has to be 180. So all of the angles of a triangle add up to 180 degrees. So looking at our diagram, we can say that the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180 degrees. The other theorem we're going to talk about today is the exterior angle theorem. So an exterior angle is formed by extending any one side of the triangle. So for example, we have this triangle right here and we extend this side outward and an exterior angle is formed. So angle 1 would be an exterior angle. Now the exterior angle theorem tells us that an exterior angle is always equal to the sum of the two non-adjacent interior angles. So the two non-adjacent interior angles would be angle 2 and 3 because they're not adjacent to angle 1, and they are the interior of the triangle. So we can say that the measure of angle 1 is congruent to the measure of angle 2 plus the measure of angle 3. Alright, so here's some examples where we need to find the missing angles. So in problem number 1, we want to find the measure of angle 1. Now, the triangle angle sum theorem tells us that all of the angles have to add up to 180. So we know that the measure of angle 1 plus 24 plus 37 has to equal 180. So we combine like terms, 24 plus 37 gives us 61. Has to equal 180. Subtract 61 from both sides. These will cancel out over here. And we get that the measure of angle 1 equals 119 degrees. All right, so 119 is our answer. All right, now number 3, we have an exterior angle. So we want to use the exterior angle theorem. So our exterior angle is equal to the sum of our two non-adjacent interior angles. So we can say that the measure of angle 1 plus 79, those are our two non-adjacent interior angles. If we add them together, it has to equal our exterior angle, which we know is 104. All right, so to find the measure of angle 1, subtract 79 from both sides. 104 minus 79 is going to give us 25. So the measure of angle 1 is 25 degrees. All right, so here we need to find 3 different angles: the measure of angle 1, measure of angle 2, and measure of angle 3. So let's start with the measure of angle 1. To find the measure of angle 1, we want to look at this triangle right here. All right, that is the triangle that has angle 1 in it. So we know that this little square right here tells us that this is a right angle, so the measure of that angle has to be 90, and the triangle angle sum theorem tells us that all of the angles inside of that triangle have to add up to 180. So we can find the measure of angle 1 by saying the measure of angle 1 plus 90 plus 43 has to equal 180. Combine like terms. Subtract 133 from both sides. And the measure of angle 1 equals, what would that be, 47. All right. So we found the measure of angle 1. So this one right here has to be 47 degrees. Now, if we want to find the measure of angle 2 and 3, what we can do is we know right off the bat that 43 and angle 2 are a linear pair, all right, because they form a straight angle, they form a straight line. So 43 plus the measure of angle 2 has to equal 180 because linear pairs are supplementary. So in order to find the measure of angle 2, we can say that measure of angle 2 plus 43 has to equal 180 because linear pairs are supplementary. Subtract 43 from both sides, and we get that the measure of angle 2 equals 137. All right, so we can write that in here. Measure of angle. All right, now to find, let's first write that in our diagram. So angle 2 is 137. Now to find the measure of angle 3, we know that this triangle right here, if we're looking at this little triangle, this littler triangle, that obtuse triangle right there, we know that this angle plus this angle plus this angle has to equal 180 because the triangle angle sum theorem tells us all of the angles in a triangle have to add up to 180. So we can write an equation to represent this. We can say that the measure of angle 3 plus 12 plus 137 equals, let me zoom out a little bit, ran out of space here, equals 180. Then we just want to combine like terms. Then we want to subtract 149 from both sides. These will cancel out, and we get that the measure of angle 3 equals 31 degrees. And we just found the measure of all three angles. If you have any questions on this, call me over so I can help you, please. Otherwise, let's move on to the next example. All right, so I want you guys to try number 7 on your own. Remember what an angle bisector does, because we're given that BC bisects angle ACD. So if BC bisects angle ACD, that means it cuts this angle in half. So angle 2 is congruent to angle 3. All right, so that's my little hint to you. Go ahead and try to do this one on your own. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. All right, so you should have gotten that the measure of angle 1 is 87, 2 and 3 are 45, and 4 is 52. How did we get that? So first of all, angle bisector tells us that this angle is cut in half, and this little square tells us that this angle is 90. So if we cut angle ACD in half, if we cut that right angle in half, each part is 45 degrees. So angle ACB is 45, and angle BCD is 45, or angle 2 and 3 are both 45. So that's how we get the measure of angle 2 and 3. Then, to find the measure of angle 1, we want to look at this triangle right here. And the triangle angle sum theorem tells us that all the angles have to add up to 180. The sum of all the interior angles is 180 degrees. So, measure of angle 1 plus 48 plus 45 equals 180. And then we just solve for the measure of angle 1, and we get 87. Then, last but not least, to find the measure of angle 4, we know that the measure of angle 4 plus 45 plus 83 has to equal 180 because the triangle angle sum theorem tells us that the sum of the angles of this triangle right here, triangle BCD, has to be 180. So set up your equation, combine like terms, and solve for the measure of angle 4. All right, if you have any questions on this, call me over so I can help you. Otherwise, let's move on. All right, so example 9, we are given that L and M are parallel. So we are given that we have two parallel lines. There's a triangle on the inside, but we can always use what we know about parallel lines cut by a transversal to help us find the measure of these angles as well. All right, so first thing, if we want to find the measure of angle 1, it's not inside of a triangle, might be a little difficult to find. So what I recommend we do here is we look at it as two parallel lines cut by this transversal. All right, and we can extend the transversal so we can easily see it. Now, angle 1 and this angle right here, which we know is 73, would be alternate interior angles. So they are congruent. So therefore, we know that the measure of angle 1 is 73 degrees as well. All right, now we know that angle 1 and angle 3 are consecutive interior angles, therefore they are supplementary. So we know that the measure of angle 1 plus the measure of angle 3 has to equal 180. And we know that the measure of angle 1 is 73, so we can solve for the measure of angle 3. Subtract 73 from both sides. These will cancel out, and we get that the measure of angle 3 equals 107. All right, so the measure of angle 3 is 107 degrees. And we can know all of that just by looking at those parallel lines cut by a transversal. You could have also said that 73 and angle 3 were a linear pair, so you could have done 180 minus 73 to get angle 3 as well. Now, we also know that angle 3 and angle 2 plus 49 would be alternate interior angles. All right, so we have to be careful. It's not just 3 and 2. It's angle 3 and angle 2 plus 49. It's this whole angle right here. They would be alternate interior angles, so they would be congruent to each other. So we can say that 107 is equal to 49 plus, let me zoom out a little bit, the measure of angle 2. So to find the measure of angle 2, just subtract 49 from both sides. 107 minus 49 is going to give us 58. All right. So the measure of angle 2 is 58 degrees. Now, we need to find the measure of angle 4 and the measure of angle 5. So what we can do is we can look at the triangle now. We can look at this triangle because we know two of the angles. We know that one angle is 73 and one is 58. So in order to find the measure of angle 4, we can just say 73 plus 58 plus the measure of angle 4 has to equal 180, thanks to the triangle angle sum theorem. All right. Then we add them together. We get 131 plus the measure of angle 4 equals 180. Subtract 131. And the measure of angle 4 is 49. All right, so then if we know that the measure of angle 4 is 49 degrees, and we want to find the measure of angle 5, we know that 4 and 5 are a linear pair. So to find 5, all we got to do is say 180 minus 49. All right, we know 180 minus 49 gives us 131. All right, you could have also said that this was your transversal, and 5 and 2 plus 1 were alternate interior. Or you could have used the exterior angle theorem and said the measure of angle 5 is equal to the two interior angles that are non-adjacent. Okay, so we could have said 73 plus 58 equals that exterior angle. All of these different ways would have worked in order to find that the measure of angle 5 is 131. All right, if you have any questions on this, call me over so I can help you. Otherwise, let's move on. All right, so we're going to skip over to 13. Now we're going to be using algebra and the theorems we just learned to help us solve for x and then find each angle measure. So if we're given a figure like this, we're given triangle QPR and we're given all of the angles, we know that the triangle angle sum theorem tells us that the sum of all the angles has to be 180. So to set up an equation to help us find x, what we would need to do is we would need to say that 4x minus 22, that's angle Q, plus angle P plus angle R equals 180. Now we just want to combine like terms. So 4x plus 10x plus x gives us 15x. Negative 22 minus 4 plus 11, that gives us negative 26 plus 11 gives us 15. So minus 15 equals 180. Then we want to add 15 to both sides. 15x equals 195. Divide both sides by 15. And x equals 195 divided by 15 gives us 13. All right, so we found that x equals 13. Now we're not done yet though. We have to go back and find the measure of each angle. All right, so we found that x equals 13, but now we have to go back and plug it in to all three of these. So 4x minus 22, we would say 4 times 13 minus 22. That's going to give us, let's see, 4 times 13 gives us 52 minus 22. That's going to give us 30. So the measure of angle Q is 30 degrees. Now, to find the measure of angle R, it's just x plus 11. So 13 plus 11, that's easy, gives us 24. So R is 24 degrees. And then last but not least, to find the measure of angle P, we would do 10 times 13 minus 4. 130 minus 4 gives us 126. So the measure of angle P is 126 degrees. All right, if you have any questions on this one, call me over so I can help you. Otherwise, let's move on. All right, number 15. In number 15, we have an exterior angle. All right, so we want to use the exterior angle theorem. Now, the exterior angle theorem tells us that the exterior angle is equal to the sum of the two non-adjacent interior angles. So we need to set up an equation to represent this. So we would say the sum of the two non-adjacent interior angles. All right, so this angle plus this angle is equal to the exterior angle. All right, now it's just an algebraic equation that we need to solve. So we combine like terms. We say 12x minus 59 equals 9x minus 8. Move all of our x's to one side, all of our constants to the other, and we get 3x equals 51. Divide by 3. And x equals 17. All right, so we solved for x, that x equals 17. Now we have to go back and find all of the angles. So we plug 17 in for x. So 7 times 17 minus 32, that's going to give us 119 minus 32, which equals 87. So the measure of JKL is 37, or 87. I don't know why I said 37. Now we want to go back and find angle J, or KJL. All right, so 5 times 17 minus 27. 5 times 17 is going to give us 85 minus 27 equals 58. Okay, so KJL is 58 degrees. Then if we plug it into the exterior angle, 9 times 17 minus 8. 9 times 17 is going to give us 153 minus 8. That equals 145. So the measure of that exterior angle, KLM, is 145. Now if we want to find the measure of KLJ, that would be this angle right here. So if we know this one is 87 and we know that this angle is 58, in order to find the measure of KLJ, what we would need to do is add them together. So 145, and then do 180 minus 145, and that's going to give us the measure of that angle. So that's going to be 35 degrees. Okay, because we know triangle angle sum theorem tells us all of the angles on the inside of the triangle have to add up to 180. So the measure of KLJ is 35 degrees. All right, now we're going to be talking about two specific types of triangles. The first type of triangle we're going to be talking about is called an isosceles triangle. All right, last time we went over the general terms for isosceles triangle, but now we're going to give each of its parts specific names. All right, so we know an isosceles triangle is a triangle that has two congruent sides, okay? And those two congruent sides are called the legs. So AB and BC would be the legs, and those are congruent to each other. All right, now the angle where the sides intersect is called the vertex angle. So angle 1 would be the vertex angle. Then the opposite the side opposite the vertex angle is called the base. So AC would be the base of our isosceles triangle. And the angles along the base are called the base angles. All right, so these are the specific names to an isosceles triangle. So 2 and 3 would be our base angles. Now we have certain theorems that tell us specific things about isosceles triangles. So the isosceles triangle theorem tells us that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So basically, if the two legs are congruent, then the base angles are congruent. So how we would write that out is using this example, we would say if AB is congruent to BC, then angle A, or 2, is congruent to angle C, or 3. All right? And then the converse of the isosceles triangle theorem tells us that if the two angles of a triangle are congruent, then the opposite sides of those angles are congruent. So basically, if the base angles are congruent, then the legs are congruent. So how we would write that is we would say if angle A was congruent to angle C, then we can say that the legs are congruent. So then we can say that AB is congruent to BC. All right, and remember the word converse just switches it around. So converse of isosceles triangle theorem is just our hypothesis and conclusion switched around. So in the isosceles triangle theorem, we're saying if the legs are congruent, then the base angles are congruent. And the converse of the isosceles triangle theorem tells us if the base angles are congruent, then the legs are congruent. All right, so now we're going to apply our knowledge of sides and angles of isosceles triangles to these problems to help us find the missing measures. So if we're given this is an isosceles triangle because the legs are congruent, therefore we know that the base angles are congruent as well by the isosceles triangle theorem. So if the measure of angle L is 68, then the measure of angle J is also 68 degrees. And then by the triangle angle sum theorem, we know that the sum of the angles has to be 180. So we can say 68 plus 68 plus the measure of angle K equals 180. So 68 plus 68 gives us 136. Subtract 136 from both sides. So therefore the measure of angle K equals 44. All right, so K has to be 44 because this is an isosceles triangle. So we found an angle K would be the vertex angle. So we found that the vertex angle is 44 degrees. All right, so in this triangle, we're given that the two base angles are congruent. So by the converse of the isosceles triangle theorem, we can say that the legs are congruent. So if XY is 12, then YZ also has to be 12 centimeters. And then in order to find the measure of angle Y, we know the measure of angle Y, we know Y is the vertex angle. And we know that the two base angles are 77, so we can say 77 plus 77 plus the measure of angle Y has to be 180 because of the triangle angle sum theorem. So we would say 154 plus the measure of angle Y equals 180. Subtract 154 from both sides. Oops. These will cancel out, and the measure of angle Y equals 26 degrees. And you're done. All right, number 5, we got to do a little algebra, but we're still using that isosceles triangle theorem. So we are given that the legs are congruent. So by the isosceles triangle theorem, we can say that the base angles are congruent as well. So in order to solve for x, set both angles equal to each other. So we can say that 4x plus 7 equals 9x minus 33. And now we can solve for x. So subtract 4x from both sides. Then add 33 to both sides. These will cancel out. We're left with 40 equals 5x. Divide by 5. X equals 8. All right, and the problem is just asking us to find the value of the variable, so we're done. All right, then number 7. We know that the base angles are the same because they're both 74 degrees, so by the converse of the isosceles triangle theorem, we can say that the legs are congruent. So in order to solve for x, set the legs equal to each other. So 9x minus 73 equals 3x plus 23. Move all the x's to one side. Move all the constants to the other. These will cancel out. You're left with 6x equals 96. Divide both sides by 6. 96 divided by 6 gives us 16. And we solved for x. So we're done. All right, so number 9. Number 9, we are just given words. We are not given a diagram. So anytime you are not given a diagram, always, always, always draw a picture. All right, so we know that we are dealing with triangle DEF. So let's draw triangle DEF. All right, so we draw, there's one side, there's another side, and there's a third side. All right, doesn't have to be the most perfect triangle, but at least we have an idea what it looks like. And then label all the vertices. So D, E, F. Now, if D is congruent to E, so we know D is congruent to E, and DE is x plus 4, so as we read through it, we're labeling our diagram. And EF is 4x minus 8, and DF is 7x minus 35. We want to find the value of x and the measure of each side. So first thing we know that these two angles are congruent. So if this is an isosceles triangle, even if it's not drawn to scale, we know that those are our base angles. So the sides opposite those angles would be our legs. So the side opposite angle E is DF, and the side opposite D is EF. So those legs are congruent by the converse of the isosceles triangle theorem, all right? Because if the base angles are congruent, then the legs are congruent. So we know that 7x minus 35 is equal to 4x minus 8. So we can set up an equation to help us solve for x using the converse of the isosceles triangle theorem. Now we just solve for x. So move all the x's to one side, all the constants to the other. These will cancel out. We're left with 3x equals, what would that be, 27? Divide by 3. X equals 9. All right, so we solved for x. We know x equals 9. But we're not done. We have to go through and find the measure of each side. Okay, so plug 9 in. Plug 9 into 4 times 9 minus 8. 36 minus 8 is going to give us, what will that give us? Why can't I do this in my head right now? 28, okay? 36 minus 8 gives us 28. So EF is 28. Then 7 times 9 minus 35. 63 minus 35 equals 28. All right, and what do you know? Our legs are the same measure as they should be. They're both 28. And then to find DE, we just plug 9 in. So 9 plus 4, DE is 13. So we first solved for x using what we know about isosceles triangles, and then went back and found the measure of each side. If you have any questions on this, call me over so I can help you. Otherwise, let's move on to our final concept of the day. All right, the second type of special triangle is an equilateral triangle. So we know an equilateral triangle means that all the sides are the same. They're all congruent. So therefore, what equilateral triangle is, the thing we need to know is a triangle is equilateral if and only if it is equiangular. So if a triangle is equilateral, it has to be equiangular. And if a triangle is equiangular, it has to be equilateral. So if the measure of angle A, let me get my pen. If the measure of angle A is equal to the measure of angle B and it's equal to the measure of angle C, then we can say that AB is congruent to BC is congruent to AC. So we can say that the measure of AB, we don't put that little line on top if we're saying the measure. So the measure of AB is equal to the measure of BC is equal to the measure of AC because it's equilateral. And if the measure of AB is equal to the measure of BC is equal to the measure of AC, then we can say that the measure of angle A is equal to the measure of angle B is equal to the measure of angle C. All right, so if it's equilateral, it has to be equiangular, and vice versa. All right, so we want to find the measure of each missing measure. So first thing we want to do is find the measure of angle C. Now, we know right off the bat, if it's 60, 60, this one has to be 60, all right? Because 180 divided by 3 is 60. So in an equilateral triangle, all of the measures of the angles are 60. So if it's equiangular, it's equilateral, and all the measures are 60 degrees. So the measure of angle C is 60 degrees. Then if all the angles are the same, that means all of the sides have to be the same too. So if AB is 9, BC is 9 feet, and AC is 9 feet as well. All right, so we can write those in. And you're done. All right, last but not least, we want to solve for x and y. So let's start by solving for x. Now we're given that PQR is an equilateral triangle, so we know all of the sides are the same and all of the angles are the same as well. So every angle is 60 degrees in an equilateral triangle. So if we know that angle R is 7x minus 3, and we also know that angle R is 60 degrees, we can say that 7x minus 3 equals 60. And now we can solve for x. So add 3 to both sides. These will cancel out. 7x equals 63. Divide by 7, and x equals 9. So we solved for x. Now if we want to solve for y, we know all of the sides are the same, so we can set any of the two sides equal to each other. It doesn't matter. So I'm going to choose QR and PR because they're smaller numbers, and I like smaller numbers. I like easier equations. So 11y minus 23 equals 9y plus 1. Subtract 9y from both sides. Add 23 to both sides. We get 2y equals 24. Divide by 2. Y equals 12. And we just solved for x and for y. All right, so if you have any questions on angles of triangles or isosceles or equilateral triangles, please call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day. Bye.